So today we're going to finish up with this new information about patterns. We're going to add in the last element to it today, and it's the word relationships. Okay, so a relationship is a connection between two things. So if you think about your family, you are in a relationship with them. So we can talk about some words. So you are a son or a daughter to your parents. That is a relationship. The connection is they're your parents, you are the child. Okay. When you think about your parents, depending on what your family situation is, they have a relationship or some type of connection. Okay. It could be a step parent, something like that, but a relationship is a connection between two things. So when we talk about math, when we talk about a relationship, this is a connection between, in our case, two sets of numbers. So we're going to look at how are these sets of numbers or these sequences, because we're talking about patterns, these sequences, how are they connected together? Okay, so let's get started. Okay, so I have a problem here about Maria and Elsie. So each of them have just gotten brand new piggy banks, and Maria has decided that she's going to save $2 each week. However, Elsie is planning on saving $4 each week. If neither of them ever spends any of their money, how would their savings compare after a year? So we can look at this and put together some things that we've already done. So first thing, we know now how to put together and finish up a pattern table. So for Maria, she started with no money and she's saving $2 each week. So $2, $4, $6. Elsie started with no money. She's saving $4 a week. So $4, $8, $12. Okay, so we know how to do that. Okay. Then yesterday we were learning how to graph our data tables that had a rule. Okay, so when we look at this, our rule goes from 2 to 4, 4 to 8, 6 to 12. So we see that that is a times, whoops, hold on, that is a times, ignore that second line, that is a times 2. Okay, rule. Okay, it's times 2 the whole way across. So when we graph this out, it should look like a line. So I've graphed out 0, 0, 2, 4, 4, 8, and 6, 12. And 12 was off the chart, but I figured out where it would be up there. And then I drew my line through it because this is a line graph showing this pattern. Okay, so we talked about yesterday, if there's a rule that's connecting the two pattern sequences, then it's going to end up in a straight line. Well, that connection, that rule connection, is really our relationship. Okay, when we write out a rule, we just say, oh, it's like a variable like m times 2. Okay, however, when we talk about a relationship, we have to be a little bit more specific. So let's look at how we would describe what this relationship is between Maria's savings and Elsie's savings. Okay, so here's what it would be. The relationship between Maria's money and Elsie's money is Maria always has half the money that Elsie has. So when we look at Maria, hers is always half as much. Or I could flip that around and I could say this. I could say Elsie always has twice as much money. So notice how I have that word always underlined, because that's true. Every single time she saves some money, Elsie always has twice as much. Maria, every time she saves money at the end of the week, she has half as much. It is a comparable relationship. At the end of the year, it's going to be true. Okay, I don't have the numbers worked out to the whole way to the end of 52 weeks, but let's just say hypothetically, let's say that Maria ended up with $120. Elsie's going to have twice as much of that, so she's going to have $240. So good for her for saving twice as much as Maria every week, because now at the end she has so much more. So that's a relationship. When we talk about in a sentence frame, this is what the connection is between the two different patterns. So let's look at another example of that. Okay. First thing, how can we find a relationship between our two sequences? Well, the first thing we have to do is figure out what our first sequence would be. So in this case, I'm starting at 0 and I'm adding 2. So that first sequence, rule A, would look like 0, 2, 4, 6, 8. And my second rule, rule B, starts at 0, and I'm going to add 6 each time. So 6, 12, and it would continue on until, 6, 12, adding 6 more, that would be 18. 6 more would be 24. Okay, so then we add in our second element, putting everything together today, guys. So we add in our second element of graphing this out. Okay, so starting out with rule A and B at 0, 0, right here at the origin. And then remember, top row is always X, bottom row is always Y. Sorry if you hear my dogs running around, guys. They're up from their nap, so hopefully they don't start barking. So my second terms are 2, 6, so 2, 6, 4, 12, 6, 6, 18, and then 8, 24, and you see how it just naturally, and I'm going to see if I can freehand this, just naturally created a line right through all of that. So that shows that rule. But now we need to talk about what is the relationship. Okay, so hold on, coming back here. So what is the relationship? So when I look at this, my rule is that I'm going times 3. So I have 2 different ways that I can explain this relationship. I can say the easiest one is always to go with the big one. So I can say that rule B is, and here's the word I'm going to use, is always, because this is a proven fact right now, is always 3 times more than rule A. Sorry about my sloppy handwriting, trying to go fast, guys. Okay, the other way I can say it, or, because there's always 2 ways to say it, rule A is always 1/3 the size of rule B. Okay, so let's look at a few more examples. So for this one, rule G, we're going to start with 3, and we're going to multiply times 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And then rule H, we're starting with 6, and we're multiplying times 2. So 6 times 2 is 12. 12 times 2 is 24. And 24 times 2 is 48. So if I were going to graph that out, I'll just show you guys the basics because this one's going to take a little bit of time. So if I was going to graph that out, the G would be the X and the H would be the Y. So our X down here would have to go from 0 to 24. So 0 here, and then I would have to count it out. It'd probably be skip counting by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It would go to about right here. Okay, and then in order to do the y-axis, I have to go from 0 to 48. So I'd have to count by 5s probably. So it would end up being 0, 5, 10, 15, 12. 5s would be a little bit much. 2, 4. I know I can't get to 48s with 2. So I probably would do 5s. So 0, 5, 5, 10, 15, 20, 25, 30, 35, 40, 45. 45. Nope. Yeah, I have to, let me look at that one. So do that again. 5, 5, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. Yeah, it would get up to 50. Okay, and then I would plot that out. But we're talking more about relationships, so that's what I'm going to move into. So we need to find what is our rule between G and H in order to write out a relationship. So when I go from 3 to 6, 6 to 12, 12 to 24, my rule is that each time I'm multiplying times 2. So pause your computer, think about how you would word that relationship out. Remember to use the word always, and when you're ready to come back with an answer, hit play again. Okay, so your relationship could be said one of 2 ways. You could start with rule G, and you could say rule G is always half the size of rule H. Or you could start with rule H and say rule H is always 2 times more than rule G, or 2 times bigger. You can kind of change a synonym in there a little bit too. Okay? So another example. Right here, I have a table that is partially filled in. The only thing that's missing is the ordered pairs. So point A is at 1, 2, point B is at 3, 6, point C is at 5, 10. Oops, missed my parenthesis there. Now it's going from left to right, so we have x on the left, y on the right, plotting those points at 1, 2, 3, 6, and 5, 10. We have our nice line going through there to show that it is a specific rule. When we look at the pattern from 1 to 2, 3 to 6, 5 to 2, once again, it's times 2. So pause for a second, figure out what your relationship statement would be. Remember that word always, it's super important. Okay, so your relationship, if you pause, hopefully you have an answer here. You could say x is always half as much as y, or you could say y is always 2 times more than x. Either way, totally fine. Okay, so I have 2 more I want to look at. So this one says generate 2 numerical sequences starting at 2 using the given rules. Then compare and explain the relationship. So both of them are going to start at 2. The first one is multiplying by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and then 16 times 2 is 32. The second one we're multiplying by 4 starting at 2. So 2 times 4 is 8. 8 times 4 is 32. And 32 times 4 is 128. And 128 times 4 is 512. Okay, so this one is a little bit more complicated. So let's look at this. So where we start, not really going to look at for a rule there because it's all starting at the same thing. So we're going to look at the very next thing. Okay, so if I do 4 and 8, the connection there is times 2. But 8 times 2 is not 32. This is a complex relationship. So this one's 8 times 4 is 32. 16 times 16 is 128. And 32, oops, I'm sorry, I'm wrong on that. Sorry, rewind. Okay, so 8 times 4 is 32. 16 times 8 is 128. And 32 times 16 is 115. So in this case, our relationship is not a consistent number going from top to bottom. So it has to be explained in a different way, okay? So we can explain it in this way. The bottom, or no, sorry, rewind. The difference, that's what I want to say. The difference I don't want to say the difference. Okay, so the bottom, yeah, I do want to start with the bottom. Okay, sorry guys, I had this answer and then the bottom sequence is always a multiple of 2 times greater than the top. So when you look at the multiplication, each one of these times 2 times 4 times 8 times 16, they're all multiples of 2. So each time it gets greater by doubling it. Okay? So that one's a little bit of a trickier one. Okay, let's look at one more. Okay, so this time we're going to start at 6 and we're going to add 2. So 8, 10, 12, 14. And on the bottom, I'm going to add 8. Okay, so 6 plus 8 is 14. 14 is 22, plus 8 is 30, plus 8, oh my goodness, is 38. Okay, so when I look at this from top to bottom, this is plus 6, this one is plus 12, plus 18, and this one is plus 24. So in this case, I can say the difference because it's adding and subtracting. So the difference between the top and bottom sequence is always a multiple of 6 in this case, because it's 6, 12, 18, 24. We could say 2, we could say 4, but it's best to say 6 because that's what it really is. It starts with 6, goes to 12, 18, 24. Okay, I know those last couple were tricky. There is a practice.